If you shrank Earth down to the size of this model, here's how big Jupiter would look next to it. But try comparing Jupiter to the Sun. Well, the Sun wouldn't even fit in frame. You'd have to zoom way, way out. If Earth were 12 centimeters or 4.7 inches across, the Sun would tower at 13 meters, roughly 43 feet. To our digital host holding his little Earth model, the Sun would look about the size of a school bus, and that's nothing compared to what's coming. Today, we're going bigger and bolder to uncover the absolute largest objects anywhere in the observable universe. One clarification first, we're talking about physical size, not mass. People often use large and massive interchangeably for planets and stars, but here large means diameter, top to bottom, while massive refers to how much matter is packed inside an object. You can have incredible mass while being physically tiny, like a dense black hole or a neutron star. Those won't make today's list because we're strictly talking size, and things are about to get enormous. In our own solar system, Jupiter reigns as the largest planet. It's so massive in volume that you could fit 1,321 Earths inside it. You could say Jupiter punches well above its weight in our solar system. This gas giant may actually be part of the reason Earth can support life at all. Thanks to its sheer size and gravity, Jupiter deflects comets and asteroids away from Earth, sparing us from the kind of impact that wiped out the dinosaurs. Even more importantly, its position in the solar system helps the inner planets maintain nearly circular orbits. For Earth, a circular orbit means a stable climate, sustained over very long timescales. Thanks, Jupiter. Now, Jupiter might be the largest planet in our solar system, but it's dwarfed by the largest planet scientists have ever discovered anywhere, Rox's 42b. Located roughly 470 light-years from Earth, this is an absolute monster of a gas giant. If Earth were a 12-centimeter ball and Jupiter measured 1.35 meters across, Rox's 42b would be as wide as an elephant, or roughly the size of a one-story house. And it's not just another oversized exoplanet. Something is genuinely strange about it. Gas giants are made of the same material as stars, mostly hydrogen and helium. The only real difference is how much mass they're carrying. Once a gas giant crosses roughly 13 Jupiter masses, it starts undergoing nuclear fusion internally and becomes a brown dwarf star. Sponsor segment. By the way, did you know there are more atoms in a single glass of water than there are glasses of water in the entire ocean? I keep running across facts like that worth sharing, but turning them into visuals has always been slow and frustrating. I'd want a simple, engaging infographic for a stat like that, and normally that means either opening a design tool myself or briefing a designer, both of which take time and often don't quite match what I had in mind. With Gamma Imagine, I can just describe what I want and work with an AI in real time to build it. I open Gamma Imagine, type a prompt, hit generate, and get options immediately. From there, I can keep refining the design just by telling the AI what to change in plain English, and after a few tweaks, it's ready. Idea to finished visual in minutes, not days. Instead of digging through endless templates, I just describe what I want, and Gamma builds it. It genuinely feels like having an AI design partner, no design skills required. Gamma Imagine is already used by more than 70 million people worldwide, and right now it's free to try for 30 days. No discount code needed. Check the link in the description for more. Back to Rox's 42b. This is a cosmic heavyweight carrying a mass of 9 Jupiters. That's too light to ignite as a star, but far too massive to have formed the way a normal planet does. Ordinary planets build up slowly, piece by piece, from the leftover debris of a star's formation, but Rox's 42b may have skipped that process entirely. Instead of growing from dust, it may have collapsed directly out of a massive cloud of gas, the same way a star forms. But because it never gathered enough material to trigger nuclear fusion, it never actually ignited. Scientists call this a sub-brown dwarf, essentially a failed star trapped inside the body of a planet. If you could drift through its thick, storm-racked atmosphere, you'd find a core still glowing cherry red with leftover heat from its formation. If you're wondering why there aren't any oversized rocky planets on this list, it's because rocky worlds simply don't grow that large. The title for largest known rocky planet goes to TOI 849b. And if Earth were 12 centimeters tall, TOI 849b would only measure about 40 centimeters across. Rocky planets generally don't grow much beyond about 4 times Earth's diameter, and TOI 849b isn't just an oversized rock anyway, it's actually the dead, stripped-down core of a gas giant that lost its entire atmosphere. So when you're hunting for the truly largest planets, you have to look at things like Rox's 42b, a world teetering on the edge of stardom. Which brings us to the next tier of bigger, brighter objects, stars. Stars are enormous, and we happen to have a fairly big one right at home. The Sun is by far the largest object in our solar system, measuring 1.4 million kilometers. about 865,000 miles to cross. It completely dwarfs both Roxas, 42 BB, and Jupiter. In our scale model, where Jupiter measures 1.35 meters across, the Sun stretches to 13 meters wide. That's the kind of size jump you get moving from planets up to stars. The Sun isn't just physically massive, it also accounts for 99.86% of all the mass in the entire solar system. Every planet, moon, asteroid, and comet combined amounts to just leftover crumbs. So we're roughly 0.14% left over from the Sun's formation. You should be grateful space is a vacuum and sound can't travel through it, because if it could, the Sun would be absolutely deafening. It's so loud from its constant nuclear activity that even from 150 million kilometers away, it would sound like a lawnmower blasting over 100 decibels directly into your ears. On top of that, roughly 10 times a year, you'd be hit with the thunderclap of an X-class coronal mass ejection, events that can release the energy of hundreds of nuclear explosions all at once. Our star is special to us, but it's neither the largest nor the most massive object out there. Neutron stars, white dwarfs, and magnetars pack far more mass, but they're all physically smaller than the Sun. They crush their mass down into a tiny space. Since we're ranking by size rather than mass, those extreme objects don't make our list. And our Sun, a medium-sized yellow dwarf, is nothing compared to what waits farther out in the universe. Take Sirius A, also known as the Dog Star, visible to the naked eye and the brightest star in our night sky. It's not the brightest, because it's the biggest though. It's just extremely close, only 8.6 light years away, making it one of the 10 nearest stars to Earth. It is bigger than our Sun, roughly 1.7 times larger. On our scale, Sirius A would measure about 22 meters across. But compared to the true giants of the universe, Sirius A is still a relatively small player. It's a bright, impressive neighbor, sure, but nothing compared to what happens once a star starts approaching the end of its life. Take Pollux, for example. It's actually cooler than our Sun, but 9 times larger. Pollux is a red giant, a star that's begun running out of fuel and has swollen to a staggering 12 million kilometers across. It's a bloated, glowing preview of our own Sun's eventual fate. This exact transformation will happen to our Sun in roughly 6 billion years. Scientists calculate that the red giant version of our Sun will almost certainly swallow Mercury and Venus, and possibly Earth as well. Impressive as Pollux is, we're about to go even bigger. Meet Arcturus, a true giant measuring 18 million kilometers across. To put that in perspective, you could line up 25 suns side by side across its diameter and still have room left over. Arcturus sits 37 light years away and is the 4th brightest star in our night sky, shining with the intensity of 113 suns. But Arcturus actually hides much of its true power. Since it's cooler than our Sun and most of its output isn't visible light, it's heat. This star pumps out 215 times more thermal energy than the Sun, making it a cosmic furnace that would incinerate anything unlucky enough to get too close. Arcturus is also one of the oldest stars in our galactic neighborhood, and scientists suspect it may actually be a relic from an entirely different galaxy that the Milky Way absorbed billions of years ago, an ancient extragalactic traveler passing through our corner of the cosmos. As massive and mysterious as Arcturus is, it's about to look almost insignificant next to what's coming. This is Betelgeuse, a literal supergiant, roughly 700 times larger than our Sun. If Earth were that 12-centimeter globe, Betelgeuse would stand slightly taller than Mount Everest. It's so large that if you dropped it into the center of our solar system, its surface would extend past the orbit of Mars and could even reach Jupiter. And Betelgeuse is dying, burning through the very last of its fuel. In 2019, it mysteriously dimmed to about 60% of its usual brightness, and for a while scientists wondered whether it was finally about to go supernova. It turned out to be an enormous surface mass ejection that threw off a cloud of dust, temporarily blocking some of its light. Betelgeuse could collapse into a supernova tomorrow, or it might hold on for another 100,000 years. On the billions of years timescale of the universe, that's less than a nanosecond either way. When it finally does explode, it'll be so bright that for weeks you'd be able to see it shining in the sky even during the day. Even a puffed-up red supergiant like Betelgeuse can't compete with the true heavyweight champion of stars, Stephenson 2-18. To fit this monster into our comparison at all, you'd have to zoom out drastically. If Earth were that 12-centimeter ball, Stephenson 2-18 would be a sphere 28.3 kilometers, about 17.6 miles, wide. That's more than 3 Mount Everests stacked on top of each other. If you swapped our Sun out for Stephenson 2-18, its outer edge wouldn't stop at Jupiter. It would extend past the orbit of Saturn, swallowing Mercury, Venus, Earth, Mars, Jupiter, and Saturn whole. It's so vast that if you flew a plane at 900 kilometers per hour around its circumference, the trip would take you 1,500 years to complete a single lap. You could fit nearly 10 billion suns, or 13 quadrillion Earths, into the volume Stephenson 2-18 occupies. And this largest of known stars shines 500,000 times brighter than our sun, 500,000 times brighter. But it sits 19,000 light years away. So despite its size and brilliance, you'd need a powerful telescope to spot it from Earth at all. So there you have it, the largest star in the universe. But our search for the biggest objects doesn't stop at stars, because there are far larger and far scarier things out there. Next up is something so vast that scientists had to invent an entirely new category just to describe it, the ultramassive black hole. Where Stephenson 2-18 was. Big and puffy, TON 618 is pure gravitational nightmare fuel, shining brighter than 100 trillion stars, simply because it consumes mass so voraciously. TON 618 sits 10 billion light years away, but if you placed it in our hypothetical scale next to Stephenson 2-18, this black hole would be roughly the size of our actual moon. With Earth as that 12-centimeter ball, TON 618 would measure about 3,160 kilometers across. In reality, TON 618 is roughly 40 times the width of our entire solar system. While we're strictly talking physical size today, it's hard to discuss black holes without mentioning mass. TON 618 packs an almost unbelievable 66 billion times the mass of our sun. It's enormous, and it's also unfathomably massive. Terrifying as it is, TON 618 is one of the biggest black holes known, but it's still not the biggest. That title belongs to Phoenix A-ICE, a black hole whose event horizon stretches 590 billion kilometers across. If Earth were that same 12-centimeter ball, Phoenix A-ICE would be a sphere roughly 5,500 kilometers in diameter, nearly the size of the actual planet Mars. This is the single largest known black hole in the universe, with a mass of 100 billion suns. That's a 1 followed by 11 zeros. It's so enormous that astrophysicists don't think it could have formed by gradually consuming stars the way an ordinary black hole does. There simply hasn't been enough time in the history of the universe for it to swallow that many stars and reach this size. Phoenix AI may instead be a primordial black hole, formed directly from the raw energy of the Big Bang, long before the very first stars began to shine. As big as that is, almost incomprehensibly big, it's still not the largest object in the universe, not even close. Let's scale all the way up to entire galaxies. Start right here at home in the swirling city of roughly 400 billion stars we call the Milky Way. It's a massive spiral galaxy, 100,000 light years across, and we sit tucked away on the Orion Cygnus arm. Basically the galactic suburbs, roughly halfway out to the edge. To really grasp that kind of distance, consider a single light year. Imagine a beam of light circling the entire Earth 7.5 times in a single second, then multiply that by every second in an entire year. You get 9.5 trillion kilometers. That's just 1 light year. Crossing our galaxy means making that trip 100,000 times over. If Earth were our 12-centimeter ball, the Milky Way wouldn't just be the size of a city or a country. It would stretch across a diameter roughly equal to our actual solar system, about 15 billion kilometers wide. That's far too large for our model to display. Just picture a single grain of sand next to the Milky Way. That grain would be the sun. It sounds enormous, and yet on the scale of the universe, it really isn't. Even our next-door neighbor, the Andromeda Galaxy, is about twice our size, spanning 220,000 light years. And then there's the true behemoth, IC LMO1, stretching out across 4 million light years. Or, believe it or not, things get bigger still. At this point, we're pushing right up against the limits of human comprehension and stretching the very definition of what counts as an object in space. Take Quipu, located somewhere between 425 million and 815 million light years from Earth, and visible in the night sky even without a telescope. Quipu is a twisted, branching rope of glowing galaxy clusters, resembling something like a nervous system spread across the cosmos. On our hypothetical model, compared to that Earth ball, Quipu would stretch 20 light years long. In reality, it spans 1.3 billion light years and carries the mass of 200 quadrillion suns. Just to be clear, a quadrillion is a million billion, so 200 quadrillion is a 2 followed by 17 zeros. Scientists believe Quipu may be the largest connected structure in the known universe. Essentially, a massive glowing chain of roughly 13,000 Milky Ways linked end to end. And even Quipu isn't the final word. There's at least one thing bigger still, and it might be almost too big to exist. The Hercules Corona Borealis Great Wall, a supercluster spanning 10 billion light years. To grasp just how absurd that is, consider that it takes up roughly 10% of the entire observable universe. Back to our hypothetical scale one final time. Earth as a 12-centimeter ball, Jupiter at a modest 1.35 meters, the Sun the size of a school bus. On that same scale, the Hercules Corona Borealis Great Wall would stretch 150 trillion kilometers, about 157 light years, long. Even on our model, these numbers stop making intuitive sense, and the Earth comparison basically breaks down entirely. The Great Wall is so enormous that even the scientists who discovered it initially thought it seemed too large to exist. Based on our current understanding of how the universe evolved after the Big Bang, a structure this size shouldn't have had time to come together at all. This cosmic anomaly challenges a lot of what we think we understand. For now, this is roughly the edge of what we can see and comprehend. But in a universe this vast, there's always something larger, darker, and stranger, waiting just beyond the horizon. And some of the darkest, most lurking things out there don't even need to be unimaginably massive to be deadly. Take a black hole, for instance. Even a fraction of a second inside one would turn you into human spaghetti. But that's a story for another episode.